So today we have with us Dr. M K Pradhan sir. He is an associate professor in NIT Raipur. He is having a PhD in manufacturing, PG in production engineering, and with graduation in mechanical engineering. His area of interest are in machining, conventional and non-conventional machining process, additive manufacturing, modeling of machining process, machining of difficult to machine materials and composites, condition monitoring, modeling and optimization of manufacturing systems, MCDM methods, decision making tools, soft computing techniques, surface texturing and surface coating. Sir is having more than 180 publications, out of which more than 90 publications are in international journals with Scopus indexed also. In national conference also he is having with international conferences also. He has his publications are also in book chapters.
NIT Raipur, and I am really honored and I extend my heartfelt gratitude to the organizer of this particular program, FDP on 3D printing and design, organized by At the outset, I would like to express my sincere thanks to Dr. Director, Head of the institution, my special thanks to Mr. Sarath, Program Coordinator for this excellent program, one hospitality. And as you can see, today's topic is quality control in additive manufacturing, where basically we are highlighting the various achieving precision, reliability, consistency. Because of the defect, including the thermal gradient, maybe the temperature variation during the melting or maybe during the cooling, and the surface roughness, which can be result in integral irregularities, deformation of the parts. By understanding how these defects from, the manufacturer can step the optimized process parameter and reduce the likelihood of the defects.
Sir, these defects are for both plastic and metal.
Maybe any part. Defect can be because the parameters are not optimized. That during the layer by layer, if temperatures are there may be porosity. For many all the parts, all the additive manufactured parts, there may be a chance that the defect can be there. This figure illustrates the formation of the defect in manufacturing part. Inconsistency may appear at the best of the energy concentration, maybe in the material amount, which can propagate throughout the scanning or detection if layering parameters are not adjusted. The thermal gradient, the surface roughness can cause the internal irregularities and deformations. Defects can be classified into geometrical defects, internal defects, and the surface defect. We have already talked about it. It can be at the macro scale or maybe in the texture of the surfaces. Already talked about geometrical defects, maybe internal defects of the surface. Geometrical defects can occur due to the like misalignments, machine calibration process problems, resulting in distortion or warped parts. Internal defects may be air pockets or voids. Surface defects can be your roughness or uneven textures, often caused by the residual powders or maybe impurities or inconsistent laser powders. Some of the geometrical defects you can see like this. Maybe your warpage, if it is deflecting like this. The blue one is the desired one. However, the red part are actually you are getting. Suppose you are like to get this kind of surface, there may be a chance that while there is a surface staircase effect may be there, or maybe there is some kind of edge losses, or maybe swelling. So these are the geometrical defects you can see. Inline defects or outplane defects. Shrinkage may be one of the cause by excessive heating or maybe rapid cooling is a common cause of these defects. It can lead to edge losses, misalignments, Non-homogeneous thermal gradient can cause warping, out of plane deformation. If the temperature isn't even across the layer, surface tension and the temperature gradient can cause shape degradation. Staircase effect, a step-like appearance on the surface due to the layer-by-layer construction, which creates dimensional inconsistencies. So these are all different geometrical defects, shape defects. That's it. Addressing these defects require careful control over the parameters, process parameters, like laser powder, layer thickness, cooling rate. By using the optimal optimal parameters, you can reduce it. Though you cannot be eradicated completely, but you can reduce it. Next type of defect is your internal defects, internal mechanical or feedstock related defects, porosity, crack. If the tiny gaps are there, voids are there, gases in between, then leads to decrease the strength, potentially cause of the failure. Cracks are generated due to the thermal stresses. Maybe layer by layer you are getting expansion and contraction during the heating and cooling process. In contrast, and the thermal gradient is too high, may produce the crack. And many times the failure are catastrophic due to this formation of the cracks. There may be a chance that there is lack of fusion that can be there while addressing the laser heating, or maybe due to this lack of fusion, there may be a weak zone within the structure, making the part susceptible to failure under load. As these areas lack of coherence between the strength. Addressing these internal defects require precise control over the process parameters again, such as energy input, scanning speed, layer thickness, etc. Mechanical defects like residual stresses, delamination, misalignment may be the cause of some of the internal defects. Understanding and controlling these mechanical defects is essential for ensuring high quality, reliable products. Adjusting parameters, cooling rate, scanning patterns, layer mounting can help to minimize these stresses. Maybe feedstock related defects which originated from the issues with raw material used in the additive manufacturing process. These defects are closely tied with the quality of the feedstock, wherein its powder filament
properties of that material.
Yes.
Similarly, like these 3D printed products, specifically any types of operations which we can do.
It is a material, yeah.
But if it is like
With plastics,
or polymer,
the testing will be slightly different. And it is what the way they are doing in the plastic products, that can be used. It is not special for the additive manufacturing. Any quality post processing process that you are using in the traditional things, that can
same method we can
perform as good as that of the software.
like the powder metallurgy products.
Yes.
So one doubt I'm having.
We have to optimize that depending upon the type of material, type of quality we require at the end product. We have to, giving that as a target, we have to optimize it. For that, many experiments, many things has to be there.
So you have to try different methods for particular product. The best one will be considered.
Yes.
So in your opinion, which method is better? Means
They have their own advantages and disadvantages.
I'm asking means power based or filament based?
Again, it is depending upon the application, the kind of strength or kind of things we require. According to that, we have to
But precision wise, which one is best? Filament or power based?
But in overall sense also, sir, if the conventional method, like simple conventional method like casting and all, what are the defects coming in the quality check? Like crack, porosity, rat tail, all these defects are
All
coming here
the
also.
things are there itself. In everywhere we have to
Here
see.
also is
Ah.
But in changing blow hole, maybe chance.
Yeah,
In the
yeah.
article, blow hole, getting blow hole.
Blow hole. Yes, presence of air, there is a chance.
Chance.
Because everywhere where there is a phase changes, liquid to solid during the
There will
solidification,
be-
there is a chance that there will be reaction with atmosphere or maybe some other particle formation. There will be contraction and expansion. The chances are there.
There. Sir, why?
Because he has taken a lot of effort for making this presentation, and it was excellent. The slides was excellent, according to me, and I think that you also have the same opinion. Because as a preliminary level or the medium level person, it is very useful to study. Okay, so that's a thing. So as a on behalf of Super, we are giving a small honor to sir. Sir, please have a